Supplier Performance Metrics in Supply Chain Analytics. In this lesson, we will learn how to analyze and measure supplier performance using real-world supply chain data. Supplier evaluation is critical for managing procurement risk and ensuring reliable operations. You will build practical, hands-on skills for extracting, interpreting, and applying supplier KPIs from public business datasets. We will use Python, pandas, and real supplier datasets to assess delivery, cost, and quality metrics. Running the cell now. Let us set up all required libraries for supply chain data analytics. These tools help you wrangle, analyze, and extract value from real business data. We import pandas for handling tabular data efficiently. NumPy is imported for numerical operations and statistics. We import OpenML to load real supply chain datasets easily. Warnings could clutter our analysis, so we import the Warnings module. We suppress distracting warnings to focus on analytical results. Running the cell now. Understanding supplier performance data. Supplier performance analysis typically uses data about deliveries, costs, and supplier reliability. Your data may include columns for order status, fulfillment times, costs, and supplier identifiers. Operations datasets can be large and messy, with missing or ambiguous data. Beginners often overlook issues such as date parsing, correct units, or duplicate supplier records. Clean, structured data enables trusted supply chain decisions. Running the cell now. Let us load a real OpenML supplier dataset that contains procurement and logistics performance for real organizations. We fetch a real supplier performance dataset, OpenML ID for 2125, for our examples. The dataset is loaded as a pandas data frame so we can manipulate it easily. We display the dataset's dimensions to understand its scale. Previewing the first 3 records gives us an initial feel for the data structure. Running the cell now. The output shows a dataset with 9,228 rows and 13 columns, indicating a sizable collection of employee records rather than supplier data. The preview reveals columns like salary, department, and hire date, highlighting key details such as job titles and dates in string format. This reinforces the lesson's point about carefully inspecting dataset contents and structure to ensure you understand what each column represents before analyzing supplier performance metrics. Inspect the output above and note which columns might contain supplier names, costs, or dates. Data structure and key columns. Our dataset contains supplier names, salary information, hiring dates, and job titles. For supplier metrics, we often select columns representing performance, time periods, and costs. Beginners should always check column data types and standardize supplier names. Running the cell now. To avoid confusion, let us look at all columns and then pick the most relevant for supplier analysis. We print all the available columns so that we know what data fields are accessible. Next, we select a few key columns to focus on supplier details, costs, and hire dates for analysis. Running the cell now. The output shows the dataset's key columns and a sample of 5 rows, highlighting important fields like supplier names, departments, gross pay for 2016, and hiring dates. Notice how the column names are clearly organized to reflect personal info, pay details, and job data, which aligns with the lesson's focus on identifying key columns for supplier metrics. Checking these columns and their sample values helps ensure the data is ready for analysis and that names and dates are in expected formats. You should always identify columns relevant to your analysis task before jumping into calculations. It is important to clean and rename columns so they match your operational analytics vocabulary. We rename the full _name column to supplier _name for clarity in our business context. Convert hire date strings to pandas datetime objects, being careful to coerce invalid values to NAT. We confirm that the renaming and date conversions were successful. Running the cell now. This output shows the first 5 rows of our dataset after renaming the supplier name column and converting the hire date to a date-time format. Notice the consistent formatting of dates in the state_first_hired column and that the salary values in 2016_gross_pay_received are numerical, which is crucial for time-based and cost analyses. This confirms our data is properly structured for further supplier metrics and time series operations. Practice: try to identify how date formats and name inconsistencies could hurt supplier reporting. Beginner example 1: Counting unique suppliers. A basic supplier metric is simply how many unique suppliers operate in your supply chain. Use pandas to compute unique supplier counts for early insights. Running the cell now. Let us find out how broad our supplier base is by counting distinct entities. We calculate the number of distinct supplier names using unique. We print the result as an operational summary. Running the cell now. This output shows there are 9,222 unique suppliers in the dataset, giving a clear count of distinct entities in the supply chain. Notice how the .unique function quickly summarizes supplier diversity, which is essential for understanding the scope of your supply base in early analysis. This simple metric sets the foundation for more detailed supplier performance or risk assessments later on. You can always slice by department or type for more detail. Beginner example 2: Average supplier cost. Knowing the average cost per supplier helps budgeting and procurement planning. We will calculate the mean gross pay received as a proxy for annual supplier cost. Running the cell now. Next, let us estimate the average annual supplier spend based on available data. We compute the average gross pay received using the mean function. We format and print the cost result for clear communication. Running the cell now. The output shows the average supplier cost in 2016 as approximately $79,504, calculated from the 2016_gross_pay_received column. This single summary number helps quickly understand typical supplier expenses, which is essential for budgeting and procurement planning. Notice how the code uses the mean function to find this central value across all suppliers in the dataset. Understanding supplier cost distribution helps in negotiations and contract management. Beginner example 3: Suppliers by department. Operations often need to view supplier support by department or location. Pivot tables help you summarize suppliers by organization unit quickly. Running the cell now. Let us see which departments work with the most suppliers. This may reveal critical operational dependencies. We group suppliers by department and count the unique supplier names for each one. The top 10 departments with the largest supplier bases are printed out. Running the cell now. This output shows the number of unique suppliers supporting each department, sorted from highest to lowest. Notice that the POL department has the most suppliers, indicating broad supplier engagement there. This quick summary helps operations identify which departments rely on the largest supplier networks, aligning with our goal to efficiently summarize supplier support by organizational unit. Intermediate example 1: Supplier tenure analysis. Assessing how long suppliers have supported your organization can reveal reliability. We calculate supplier tenure by comparing hire date to end of 2016. Running the cell now. Duration is a key dimension in supplier performance. Let us compute years of service for each supplier. We define December 31st, 2016 as the reference end date for tenure calculations. The difference between this and the hire date gives us tenure in years. We print a preview showing suppliers and their estimated years of service. Running the cell now. Here we see the first 5 suppliers with their calculated tenure in years, measured from their hire date up to the end of 2016. Notice the tenure spans from just over 2.5 years to more than 30 years, showing a wide range in supplier longevity. This output confirms our calculation correctly quantifies how long each supplier has supported the organization, setting the stage for deeper reliability analysis. Longer tenure often correlates with supplier trust and institutional knowledge. Intermediate example 2, high-cost supplier identification. It is important to identify suppliers with the highest costs for negotiation or risk review. We will rank the suppliers by their total gross pay received. Running the cell now. Pinpointing your largest suppliers is essential for procurement negotiations and cost control. We aggregate total gross pay for each supplier by grouping and summing. Printing the top 5 shows suppliers with the highest year total cost. Running the cell now. This output shows the top 5 suppliers ranked by their total gross pay received in 2016, highlighting those with the highest costs. Notice the descending order, which makes it easy to identify which suppliers have the largest financial impact. This ranking is key for targeting negotiations or risk assessments based on where the most money is spent. Keep an eye on concentration risk. Too much spend with one supplier can be a business hazard. Intermediate example 3, supplier cost per department. Comparing cost structure by department highlights which units rely most on suppliers. We calculate and sort cost by department using Group B. Running the cell now. Let us develop insight into which departments have the greatest need for supplier management. We group by department and sum all supplier costs per department. Here are the top 10 departments by total supplier cost. Running the cell now. This output shows the total 2016 gross pay received by suppliers, grouped and summed by department, then sorted from highest to lowest cost. Notice that the POL and FRS departments have the largest supplier costs, indicating they rely most heavily on outside services. This helps us understand which departments drive overall supplier expenses, aligning with the goal of comparing cost structures by department. If you want to deepen your knowledge, watch supply chain data analytics tutorials on YouTube. Try searching the Supplier Metrics Data Analytics Python for relevant walkthroughs. Advanced Example 1, Supplier Diversity by Department. Diversity of supplier base can reduce supply chain risk. We calculate the proportion of a department's supplier spending with the top supplier. Running the cell now. Let us measure supplier concentration risk within each department. We group by department and supplier name, summing spend for each pair. Fraction of spend with each department's top supplier is calculated by dividing largest supplier spend by total spend. We print departments most dependent on a single supplier. Running the cell now. This output shows the proportion of each department's total supplier spend concentrated with its top supplier, highlighting potential supply chain risk areas. For example, the MPB department relies heavily on a single supplier for nearly 87% of its spend, signaling low supplier diversity. This metric helps us identify departments where diversifying suppliers could improve resilience. A value near 1 means a single supplier dominates, which is risky. Advanced Example 2, Trend in Supplier Growth. Tracking supplier additions over time can reveal trends in sourcing and procurement strategy. We will compute number of suppliers hired each year. Running the cell now. Let us look at how the supplier base changed over the years. We ensure the year_first_hired column is numeric for valid grouping. Group by hire year and count unique names to measure new supplier activity. Outputting the full trend allows us to see spikes or drops in supplier onboarding. Running the cell now. This output shows the yearly count of unique suppliers first hired, revealing a clear upward trend in supplier additions over several decades. Notice how supplier growth accelerates particularly from the 1980s onward, reflecting possibly an expanding sourcing strategy. This confirms the code's intent to track supplier growth over time by grouping and counting unique suppliers by their year of hire. Sudden growth may indicate strategic shifts or contracting policy changes. Error handling example, missing or invalid dates. Real-world datasets often contain missing or malformed dates. We will count records with invalid date_first_hired fields. Running the cell now. You should always review data completeness for critical fields like dates. We sum all cases where the hire date is missing or was not parsed. Reporting this quickly surfaces data quality risks that affect tenure metrics. Running the cell now. This output shows that there are 0 suppliers with missing or invalid date_first_hired entries in our dataset. This confirms that, in this case, the date field is complete and well-formed, allowing us to proceed without needing additional error handling for missing dates. It's an important step to validate data quality before further analysis. You can decide to filter out invalid data or impute estimated values depending on business rules. Error handling example: duplicate supplier records. Duplicates in supplier names can distort metrics such as unique supplier counts. We demonstrate how to check for duplicate entries. Running the cell now. Let us detect repeated entries so we do not double count or misrepresent supplier data. We flag duplicates based on supplier, department, and date columns. Printing the count makes it easy to spot repeated or erroneous records. Running the cell now. The output shows there are no duplicate supplier records based on the combination of supplier name, department, and hire date. This indicates our dataset is clean in this aspect, ensuring accuracy when counting unique suppliers. This check is crucial for preventing distorted metrics due to duplicate entries, aligning with the lesson's focus on error handling. You should always investigate and resolve duplicates for reliable analysis. Error handling example: inconsistent columns or units. Supplier cost data may be unintentionally stored as strings or with currency symbols. We check for non-numeric entries and convert costs to float. Running the cell now. Unit checks reduce analysis errors and make your insights more trustworthy. We coerce all supplier cost entries to numeric, setting failures to nan. We print the number of entries that cannot be interpreted as a valid cost. Running the cell now. The output shows there are 100 invalid entries in the 2016_gross_pay_received column after attempting to convert values to numeric, indicating some costs couldn't be parsed as numbers. This highlights the importance of error handling when supplier cost data might include non-numeric strings or currency symbols, which can cause issues in calculations or analysis. Identifying these invalid entries allows us to clean or address inconsistent data before further processing. If large numbers of costs are missing or invalid, review source system configuration or raw input. Best practice: KPI calculation and reporting. Reliable supply analytics start with clean, aggregated data. We will create a simple cost and tenure dashboard per supplier. Running the cell now. Automated KPI tables are at the heart of supply chain performance analytics. We aggregate total cost and the longest tenure for each supplier using Group B and AG. A summary data frame is built, ranking suppliers by cost for executive dashboards. We present a preview of top supplier KPIs. Running the cell now. This output shows the top 10 suppliers ranked by total cost, with aggregated gross pay as a measure of spend and maximum tenure indicating relationship length. Notice how grouping by supplier and summarizing key metrics provides a clear, concise KPI snapshot essential for reliable cost and tenure reporting. This aggregation step lays a solid foundation for building an effective supplier cost and tenure dashboard. This approach can be expanded for more complex dashboards, such as monthly views or trend lines. Want more advanced dashboards? Check advanced supply chain analytics videos on YouTube. Best practice: time series grouping. Often, you will need to summarize supplier spend or activity over time. We consider cost by year to spot trends and seasonal patterns. Running the cell now. Time trees and Group B are standard tools for operational time-based insight. We group supplier costs by year of first hire to see yearly totals. Recent year's data is printed for fast trend analysis. Running the cell now. This output shows the total gross pay received in 2016, grouped by the year employees were first hired. Notice the variation in spend, with some years like 2013 and 2014 having notably higher totals, which could indicate hiring trends or retention effects influencing annual costs. This grouping helps us identify patterns in supplier spend over time, supporting better budgeting and resource planning. Comparing different periods reveals trends in sourcing and supplier performance. End-to-end example, supplier risk heat map. Let us identify top suppliers by cost and tenure for risk-focused supply chain management. We will export these results as a table. Running the cell now. You now have a small but meaningful supplier risk dashboard that operational leaders can use. We select the top 20 suppliers by cost and tenure for risk review. Results are saved to a CSV file for easy sharing with the operations team. For transparency, we print the exported table here. Running the cell now. Here, we see the top 20 suppliers sorted by highest total cost and tenure, highlighting those with significant financial impact and long-standing relationships. Notice how the table prioritizes suppliers with both large spend and extended tenure, aligning with our goal to identify key suppliers for risk-focused management. Exporting this table allows for further analysis or sharing with stakeholders in supply chain risk reviews. Now opening the exported supplier risk table file so you can review and share actionable insights. You can explore the CSV with any spreadsheet tool or visualization dashboard.